Hey y'all, welcome back, Pre-Algebra. Getting started on our new week of lessons here, starting with lesson 105. I hope you guys are doing well. I'm really looking forward to seeing you guys on Zoom tomorrow. I am just so proud of you guys for how well you've been doing through all of this, how you've persevered, how you've kept doing your work. Even though I know things are different right now and I know that things don't look the same or feel the same, but you guys are doing such a great job. And I've been so impressed with how well y'all have adapted to all of this. And I'm so thankful for your patience and just the fact that you're still working so hard and you're so close to the end. So just keep going, okay? You're going to finish strong. Keep your eyes on the prize, okay? So summer's around the corner. So let's go ahead and get started on this lesson. Today, this lesson talks about a few different things. It's a little bit of a longer lesson, but we've got a couple of short ones this week too, so it'll be balanced out. We're going to talk about surface area of a right solid today, surface area of a sphere, and more on roots. So volume, which we talked about recently, that is when we're talking about a three-dimensional figure and we're trying to find how much space fills up the inside of that figure. Surface area is talking about how much space covers the outside of a figure, okay? So as we go, I'll give you a couple of examples of that so that you can see. But like real world type stuff, if you were asked like how much water it takes to fill up a coffee mug, that would be volume. That would be how much space it fills up, okay? If you were asked how much or how large the label of a can is, that's going to refer to surface area, okay? Because that's labels go around the outside of a can. So you just have to pay attention to, okay, are we talking inside or outside here, okay, to determine the difference between volume and surface area. Because the way that we calculate them is very, very different, and you're going to see that today because we're going to look at the formulas, not necessarily formulas, but the process for how we find the surface area, okay? So let's go ahead and get started. Let me pull up our first little image here. Okay, so here we've got a figure that is actually a rectangular prism. You can tell because it's got rectangular bases, and then it's a prism because there's, two bases that are connected by four sides, all that good stuff. So we want to find the area of each side in order to find the surface area, find the area of each side, and then add them all together, okay? So it's kind of like perimeter but in 3D, okay? So like normally with perimeter we would just add up all the sides. With surface area we are going to find the area of these sides and then add up all those areas, okay? So that's the goal here. With rectangular prisms like what we're looking at here, each one of these sides is actually going to have a complementary side. So that means it's the same as that side, but it's on the other side. So each one of these sides is going to have a friend on the other side that matches its same measurement. So each one of these is going to be worth twice as much, really. So we could say like there's going to be 2 green sides, there's going to be 2 red sides, and then there's going to be 2 blue sides, okay? Because just like there's a green side in front, there's a green sized shape in the back. And just like there's a red sized shape on top, there's a red sized shape on the bottom. And just like there's a blue side shape on the side, there's a blue sized shape on the other side, okay? So we're actually measuring each one of these, finding the area of each one of these, but then we're going to double each area because we know there's technically 2 of each of those sides in this figure, okay? So let's look at that. If I can get my pen to work. There we go. Okay, so we are going to have the green, which actually, you know what? Let's do it this way. I'll just make a dot for the green, and I'll make a dot for the red, and I'll make a dot for the blue. Okay, so we'll know which area goes with which side. And then we also, I'm going to put this on here just so we don't forget. We want to remember that that's actually 2, that's actually 2, that's actually 2. Okay? So let's look at our formulas. For area of a rectangle, remember it's always important to keep in mind what shape are we finding the area of. In this case, they are all rectangles, so it's all going to be the same. That will not always be the case. Okay, sometimes we'll have triangular prisms or something like that where we'll have other shapes to consider. And always remember, those formulas are different. Okay, so we gotta make sure we're being conscious of that. So we can look at our green side and say, okay, area equals length times width. Well, I know my length is 6. And then my width is actually going to be the same as this side back over here, which is going to be 3. So let's plug those in. I've got 6 for my length, 3 for my width. So 6 times 3 is 18. So I've got that one. Now don't forget, we're going to multiply that by 2, okay? So 18 times 2, we'll just leave that there for now. Let's look at the next one. So the area of the red rectangle, we've got a length of the red rectangle of 6 because that matches that bottom side. Then we've got a width of the red of 5 because that matches that bottom side as well. So 6 times 5 equals 30. Now don't forget, we're going to have to multiply that one by 2. Very good. Okay, so then let's look at the last one, which is the blue, and that one's clearly labeled. So we've got a length of 5 and we've got a width of 3. So we're going to plug in our 5 and our 3, and that's going to give us 15 times 2. So now we've got 18 times 2, which was 36. We've got 30 times 2, which is 60. And we've got 15 times 2, which is 30. So now I just have to add those together. So this is the area. Let me just kind of show you with my colors here real quick so we don't forget. This top one is the area of 2 green sides. The middle one is the total area of 2 red sides. And this bottom number is the total area of 2 of the blue sides. So that's 6 sides, which is how many sides this shape has. So now let's add all those together. So that would be a 6. Then 3 plus 3 plus 6 is going to be 12. So 126 centimeters. That's kind of centimeters. Centimeters squared. Because remember, area is always squared. Okay? So rewind real quick, recap. All you're doing is finding the area of each side and then adding them all together. Okay? Let's see if we can find another example. So let me open this up real quick. All right, so let's look at this lovely figure. So this one, if you notice, has triangular shaped bases. So this is going to be a triangular prism. Very good. So for this one, we have this red side here, which we'll call the base. And we know that it has a matching side on the back, okay? So there's going to be 2 of these red sides. All right, and so then we see this side over here, which is green. So there's going to be 1 green side. And then there's going to be a blue side on the bottom that we can't really see, okay? But if we were to draw out the lines behind it, we could see that there's a blue bottom that we don't know if it's going to be the same. So that's probably going to be its own thing. And then the last little one we have is a back side on here, which we also can't see. But if we drew this line kind of on the back there, this is really hard to see when I'm just like scribbling colors all in the same place. I hope you guys are getting what I'm saying. 3D figures are not that easy to clearly illustrate whenever you don't have, like, can't hold it in your hand and look at it. So I hope you guys are able to kind of see what I'm going with here. But anyway, I know the red shapes are triangles, okay? And so the area of my triangles, it's very, very important to remember that the formula for area of a triangle is different than a rectangle. So that's actually going to be base times height divided by 2, okay? Then the green side is a rectangle, so that's length times width. Same thing for the blue and the purple sides, okay? I'm running a little out of room here, so you'll have to work with me. Oops. Well, having a hard time here. Length times width. There we go. Area equals length times width, area equals length times width. Okay, so now let's look at the triangle. So we know we have a base and a height of 3 and 4, so let's plug those in. We've got 3 times 4 over 2, so that's going to end up being 6. But now remember there's 2 of those, okay? So that's going to be important. I'm going to put times 2 on there so we don't forget. Then we've got our green, which we can see is going to be 5 by 6. So that'd be 5 times 6. I'm not even going to write it out because we're running kind of low on room here. So I'll just write 30. 5 times 6 is 30 for that one. Well, I'm trying to write it. My pen's not liking me at the moment. There we go. So we've got 6 times 2, we've got 30. Then for the blue, we've got 6 by 3, so that's going to be 18 because it's just a rectangle, so we just multiply. And then for that back side, we've got 4 by 6 because the 6 there is going to correspond with the 6 here, okay? So that's going to be a total of 24. So now we've got 2 6s, which was 12. We've got a 30. We've got an 18 and we've got a 24, and all of those need to be put together. Okay, so we add all these on the right, and that's going to be 14. Carry the 1. So then we add all of these, and that's going to give us 8. So it should be 84, and we are in centimeters. And remember, this is an area measurement, so it's still squared. Awesome job, guys. I hope I'm not losing you. Stay with me. This is not the most riveting of subjects. I know. I'm sorry. It's actually more fun when you can be hands-on with it. Unfortunately, we can't really do that together right now. I mean, I'm so sorry. I love to do more of a hands-on thing with this. So just bear with me. You guys are doing great. We're almost done, okay? Let's look at the next one. So we've got... Oops. Let's look at, oh, there it is. So if we've got a can of soup, which I referenced earlier, if you remember, I talked about the label. It says, what is the area of the label on a can of soup with dimensions as shown? So then B, the total surface area. Okay, so here's the deal. We can't really tell what shape the can of soup is. So what I'm going to do is just sketch this out real quick as what's called a net. So like if we were to unroll that label that's around the can, it would actually look like a rectangle. And then the rectangle would have like these 2 circles attached to it, which really either way with like where you put them, but those circles are going to be the top and the bottom. Okay, so like if we were to unroll it, then we would have a circle on the top, circle on the bottom. So just to find the area of this label here, so this rectangular part here is the label. So just to find that area, we would need to know this distance, obviously, and this distance. So now I didn't label this can of soup, so let me give you some measurements here. This side is actually 10 centimeters. This top distance up here, from here to here, is actually going to be 7 centimeters. And so if we are trying to find the area of this rectangular space, we know that this is 10, okay? This corresponds to that same side. Now, the problem comes in when we're like, but wait, this piece right here that when I unwrapped it, it looks like a rectangle. This piece right here actually corresponds to the distance that's going all the way around the lid, which makes a circle. And if I wanted to find the distance around a circle, I would use the, what is that? Oh, yeah, circumference. That's totally what you said. I know, good job. So the circumference formula, which is C equals pi times diameter. Okay, so let's go ahead and plug that in. So we know that C equals pi, which this problem actually also says to use 22 over 7 for pi. So I'm going to use 22 over 7 times my diameter, which remember, if my radius, my diameter here that they give me is that distance across the circle, that's going to be positive 7. So now look what happens. If I do that, 7 is not a fraction, but I can turn it into 1 by putting it over 1. Now when I multiply, I can cross simplify my 7s, which would give me a circumference of exactly 22 centimeters, which would make my distance of this side over here exactly 22 centimeters. Because again, this side right here is really just the stretched out version of the distance around that circle. Okay, so now to find the area of my rectangle, all I have to do, I'm going to come up here to the top so you can see, all I have to do is length times width, which would just be 22 times 10, which would just be 220 centimeters squared. All right, good. Now, I don't really have enough room to work out the total surface area part, but all you would have to do to find the total surface area is then use your area of a circle formula to find the area of the top and the bottom. So that's 2 circles, remember. And for both of them, you would just use area equals pi r squared. Okay, then once you have that, you just add it to the rest. Okay, good job. We're running low on time because I don't want to take 25 minutes of your time to watch this video. So we're going to go ahead and move on to the next one. So, oh, that's not what I wanted to do. I wanted to open. Okay, so let's look at, we're going to talk about the surface area of a sphere really quickly. So the surface area of a sphere formula is just 4 pi r squared. So let's look at how we can just plug that in. So if a tennis ball has a diameter of about 6 centimeters, find the surface area of the tennis ball to the nearest square centimeters. So also real quick, let's just review. A sphere is actually just a 3-dimensional circular figure, like a ball, okay? And that's what it's talking about here, a tennis ball. All right, so to find the surface area of a tennis ball, we would just take this formula, which I gave you up at the top, surface area equals 4 times pi times r squared. So the 4 is not going to change. That's going to stay a 4. For pi, I know that I can always plug in 3.14. Then for the radius, they're telling me the diameter is 6. So if the diameter is 6, then that tells me that the radius has to be 3. Because remember, the radius is just half the diameter. So times 3 squared. Order of operations tells me I do my exponent first. So 3 squared is 9. So then I'm still multiplying 9 times 3.14 times 4. Okay, so then when I multiply all that out, I'm going to end up with approximately 38.5. So I'm doing my little approximately 38.5 centimeters squared. Okay, so it's just plugging in values to the formula. That's all that is for surface area of a sphere. All right, almost done, guys. One last thing. So let's look real quick at more on roots. So when we're talking about more on roots here, we're just going to talk real quick about the fact that whenever you're finding the square root of something, remember that's the opposite of squaring it, okay? So if I said find the square root of 25, okay? So let me just use words. Find square root of 25. Well, remember, we're looking for what multiplies by itself to give me 25. So I'm pretty sure most of you right now are thinking 5 works for that. Totally works for that. Is there any other number that also multiplies by itself to give us 25? So positive 5 times positive 5 gives us 25. What if we take negative 5 times negative 5? We also end up with positive 25. So both of those would give me a positive 25. So technically, the square root of 25 could be positive 5 or negative 5. Now, for now and what y'all are doing in class, you generally only need to know the positive answer whenever it asks you to square root. You don't always have to have one version where it's positive and one version where it's negative. But this is actually just talking about the fact that it technically could be positive or negative. So let's look at a couple of those examples. So we could have the one we just talked about, Oh, well, we already talked about that one. 2 square roots of 25, 5 and negative 5. Another little just example that I thought I had made a thing of, but I guess I didn't, would be if we did what is the cube root of 64. Well, remember, cube root is the opposite of cubing something. So it's asking what times itself gives me 64. Okay, so short version, 4 times 4 times 4 gives me 64. So therefore, the cube root of 64 has to be just 4. Okay, what if I said find the cube root of negative 27? Well, so far we've said that positives or negatives could work when we're talking about a square root. But if we're talking about a cube root, remember, we're talking about what times itself gives us a negative 27. Well, I know 3 times 3 times 3 gives me a positive 27, and they all have to be the same. So they either all have to be positive or they all have to be negative. If I make them all negative, then negative 3 times negative 3 equals 9, positive 9. Positive 9 times negative 3 is going to equal negative 27. Okay? And that's it. You guys are set. This one was a long one. Hang in there. The others are going to be shorter, I promise. Hope you guys have a great week. Bye-bye.